What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines as we continue our work with solving exponential and logarithmic equations. The last time in the last video, we took a look at the fundamental property of logarithms and how we could use that and exponential and logarithms as inverse operations to solve some types of equations. Today we're going to take a look at additional properties of logarithms, and these properties are going to help us to rewrite equations in methods that are going to be convenient for us as we progress. So we're going to have three properties for logarithms that are similar to properties that we had with exponential equations: the product property, the quotient property, and the power property. If you may recall from exponential functions that any exponent with base b, if you have b to the r times b to the s power, we're assuming b is not equal to 1, and we're assuming here that r and s and b are all real numbers. If this is the case, then we can simplify as, b to the r plus s power. So when multiplying two bases that are the same, we can add together their exponents. The same thing can be true for the product property with a logarithm, or a similar expression. So when I'm multiplying together two variables as an input for the logarithm, that's the same as adding logarithms with the same base, where one has one of those expressions and the other logarithm has the other expression. So the product property, when you multiply things with inputs of a logarithm, you can add two separate logarithms where each logarithm has one of those inputs that you multiply. You can also go in reverse. So we could simplify by taking this expression where you're adding two logarithms together. Because their bases are the same, we can multiply their inputs. The quotient property for exponential functions, if you had b to the r power over b to the s power, we subtracted r minus s. The equivalent property for logarithms would say that if you have two variables or two expressions that you are dividing within the input of a logarithm, then you can subtract the logarithm of the numerator by the logarithm of the denominator. And also vice versa. So if I have two logarithms that are being subtracted, I can divide their input values. The power property for exponential equations said that if I have b to the r power, and I'm taking that expression to the s power, this would be b to the r times s power. Now, this is going to be rewritten a little bit different for logarithms. So if I have an exponent in the input for the logarithm, so that's what we see here, we have r to the s power. I can rewrite this as s times the logarithm of r. So notice the bases do not change. The input value does not change. I'm taking the exponent and I'm rewriting it as a coefficient of the logarithm. So we're going to use these three properties. You can write those down. We're going to use them to rewrite equations that's going to allow us to simplify the solving process in the future. For right now, let's just work on applying one or multiple of these problems to single expressions. So in problem number 2, what I can see here is that I have two logarithms that are being added together. They both have the same base, and so this falls along the product property. So what I could do, instead of writing them as two separate expressions, what I could do is write them as a single expression where their input variables are going to be multiplied. So log base 2, the base does not change, of 7 times 5. Or if I wanted to simplify that a little bit further, log base 2 of 35. So this is a way I could rewrite the equation into a single term when it's in two terms. Let's take a look at b. b is going to incorporate multiple properties of logarithms. Now I may see that there's an addition here of two logarithms. So two different terms are being added together. But I also may notice that this first term has a coefficient. So I can simplify this first term using the product property. So instead of writing this as a coefficient times the logarithm, in this case the natural log of x, I can bring this coefficient into an exponent. So this could be written as natural log of x squared. And then I still have the natural log of x plus 6. So what I did was use the power property with the first term. Now I can combine the two terms because they're being added. I'll use the product property and multiply their input values. So x squared times x would be x cubed. X squared times 6 would be 6x squared. So this simplifies to the natural log of x cubed plus 6x squared. Now let's take a look at C. In C, there is no power property this time, but there is a quotient property. So I have a subtraction of two logarithms. I have a subtraction of two logarithms with the same base. So I can divide their input values. So this would then be the natural log of x plus 2 over x. And remember, we can only simplify fractions if they have factors, not terms, but factors that would divide to give you 1. And in this case, it does not. So this would be my simplified term. So what this is allowing us to do, these properties are allowing us to rewrite expressions. Let's take a look at another example where it says use the power property of logarithms to rewrite each term as a product. Essentially what we want to do here is notice that we have the natural log of 5 to the x power. So and if you think about solving, we want to get the x out of the exponent. Well, one of the ways that we could do that is to do the power property. So using the power property, I can take this from an expression where the input has an exponent to making that exponent a coefficient of the logarithm with the same input. So my input value would be 5 to the x power. If you need to, you could put parentheses around here. So the exponent becomes the coefficient. So this would be x times the natural log of 5, which if we think about solving would be nice for us because we could then divide by the natural log of 5 to get x by itself. In B, we have a similar circumstance. So we have log base 10 of 32 to the x plus 2 power. So I'd pull x plus 2 out as a coefficient. It's an entire exponent. And then it'd be x plus 2 times log base 32. Or sorry, log base 10 of 32. Now, if you wanted to, you could distribute this throughout, but we could leave it as such for now. In C, there's a little bit more work to do here, because it gives us the square root of x. So again, this is essentially our input is the square root of x. But remember, the square root of x can be written with a fraction exponent of 1/2. So this is the same as log of x to the 1/2 power. Then I can use my power property to bring the 1/2 as a coefficient. So 1/2 log of x. And this would be a rewritten version of the term. So here we're just using the power property to get rid of exponents if that were to benefit us in the solving process. Now let's look at a problem number 4. It says use the properties of logarithms to write the following expressions as a sum or difference of simple logarithmic terms. So in problem 2, we took the properties of logarithms to reduce the number of terms, to take equations or expressions with 2 terms and bring them to 1. Now we're going to go the other direction. We're going to use the properties of logarithms to create multiple terms. So what I see here in 4a is inside the expression, I have 2 variables that are being multiplied. So I can use the product property. Again, the product property says that if the variables are being multiplied, I can write them as separate logarithms that are being added. So this would be log base 10 of x squared plus log base 10 of z. Notice again that the base stays the same. Now I can also apply maybe the power property here with the first term. So I could write this as 2 log base 10 of x plus log base 10 of z. And this would be a simplified expression, or an expanded expression, written as a sum here of simple terms. In B, D is going to take a little bit more work, because notice that we have a square root here. So again, I probably want to get rid of that square root and write this with rational exponents. So this would be the natural log of x over x plus 5 to the 1/2 power. So the x over x plus 5 is in parentheses here, so I need to get rid of the 1/2 power first before I can get into that fraction. And so I can use the power property to eliminate that 1/2 power, or bring it out as a coefficient, not eliminate it, but make it a coefficient. So this would now be the coefficient 1/2 times the natural log of x over x plus 5. Now we have a quotient, two terms that are being, or two expressions that are being divided within the logarithm. So I can split this apart into two separate logarithms. Now the 1/2 coefficient is going to go with each. So I would have 1/2 the natural log, or log base e, of x minus, you subtract when dealing with a quotient, minus 1/2 the natural log, or log base e, of x plus 5. So here based on how the equation was written in the order of the operations, we had to enact the power property first and then get into the quotient property. C looks pretty complicated. But if we break this down a step at a time, we can still see some of these properties being applied. So here I have the natural log of e times x squared plus 1. I'm going to change this to the 1/2 power, divided by 2x plus 5 to the 3rd power. So notice here in the order of operations, we probably want to take care of the multiplication and the division first. So I'm going to need a little more room here. But what we're going to do is we're going to have the natural log of e. We'll come back to that. The natural log of e. And then I have a multiplication here, so plus the natural log of x squared plus 1 to the 1/2 power. And then minus, because we have a fraction, so the denominator would be subtracted, minus the natural log of 2x plus 5 to the 3rd power. Now I can simplify this a little bit further. Remember that the natural log and the exponential base of e are inverse operations. So the natural log and e would invert each other, would cancel each other's operation out to leave us with 1. Then if I simplify the second term, I can enact the power property here. So I would have plus 1/2 the natural log of x squared plus 1, minus, I can do the power property again with the final term, so minus 3 times the natural log of 2x plus 5. And so here I'm using all of our properties. I used all 3 of our properties to expand this expression. Now notice that I cannot simplify this any further. You might see this x squared here, but that x squared is part of a term that's being added within some parentheses. So I cannot break that up without the 1 also being squared, or that expression being squared. And I don't have any kind of a addition property where I can break up or rewrite expressions that are being added within the input of an expression, and so I cannot do anything with those terms. Okay, so here what we see is some examples of how to use our 3 properties, additional properties of logarithms. If it benefits us to use them to simplify, we would do so, as in problem number 2, to reduce the number of terms. Sometimes it would benefit us to get rid of an exponent, which we showed in problem number 3. And sometimes it's going to benefit us to expand terms, as we did in problem number 4. So we want to have all of those skills, and as we progress into solving, we're going to see different situations where we want to apply different techniques. And this is a good place to stop for today. As always, thank you guys for tuning in, and I'll see you soon.